Hello friends, welcome to another interesting video in Rect Professor Python Learning series. In this video we are going to see a Python program that simulates the free Bitcoin roll. Now if you're wondering what free Bitcoin Faucet roll is, you head over to this website Free Bitcoin and they have this faucet where you get arrangement of numbers. If you get a number between 0 to 9885, you get 5 satoshis. If you get number between 9886 to 9985, you get 52 satoshis, and likewise if you get 10,000, you get 5,16,000 satoshis, which is equivalent to $200. But the probability of getting a number from this range is higher as compared to this range, and the probability is decreasing because these numbers are very small, because as you can see these are 999, 4, 5, 6 and 7, so just 4 numbers here. But somehow I get a feeling that not only the probability decreases as we go down, but this is programmed for getting a higher probability here and lower probabilities as we go down, and that can be simulated with assigning weightage to pseudo-random choices, and I'll show you in a bit how we can do that. So let's head over to this code. So I need a list. The first list should have numbers from 0 to 9886, so I use a for loop and I append items in that list from 0 to 9886. Would that include 9886? No, because we do not want to include 9886. So then we create lists, and as you can see, if we check any of the lists, so lucky one is a list of numbers that go from 0 to 9885, and similarly lucky 2 will have 9886 to 9985. Is that what we wanted? Yes. Creating lists of all these ranges is the first step, and that is done in this cell. And by the way, this last list has just one number, which is 10,000. Okay, so that is done. Then what we do is we use the random module, and in random module we use the method random.choices. So what does this method do? Let's check this out. I'm just going to copy this code and I'll insert a new cell, and I'm going to paste it here. So if I apply random.choices, it is going to pick up one thing randomly out of these choices in the list. And by the way, because I have specified k is equal to 1, so that is why it will pick up just one random thing from the list that I provide. If I make 2 here, it will select 2 random things from this list, but I need one random list out of all the lists that I have. So I can use random.choices and I pass all the lists that I have, and one list will be outputted. So let's see, I have roll list. So if I run it, it has selected the first list, and if I run it again, it has selected the first list again. Now you might be wondering why is that happening, because the first argument of random.choices is list from which we want to select a random thing, and then we have the weightages. So we provide a list of weights corresponding to these options. So lucky 1 has a weight of 100, lucky 2 has a weight of 10, lucky 3 has a weight of 1, and so on. If I do not specify these weights, then all the lists are equally likely to be selected. But we do not want that here, because I want the first list to be selected most of the times and the last list to be selected the least of the times. So this is what random.choices do. It'll hardly select lucky list 6 and lucky list 5 because they have is selection weightage of 0.01 and 0.001 as compared to 100, which is associated with lucky 1. So if you understand this snippet of code, everything else is pretty easy. So what we are doing is we are selecting one list out of all these. Here in this code, I select one list. So one list will be selected randomly, but selection of this list has a higher weightage and the selection of this list has the least weightage. The output of, and now comes the tricky part, the output of roll list is going to be a list of lists. Although we have just selected one choice out of this entire list, we could have selected 2 things also, 3 things also, and in that case this roll list would be a list of 3 choices, 3 random choices, a list of 2 random choices if k was 2. But now k is 1, so roll list will be a list of just one list. So that is why it is important to understand that when in the next step, from within the list, because it is very likely that lucky 1 list will be selected, and from within the lucky 1 list we need to select a random number, because this roll list is a list of lists and this list contains just one list. So we are going to select the only list which is present there, which is placed at index 0. So from the only list which is selected randomly, we select a number by random.choice, and if that number is present in lucky 1 list, we'll say you want 5 satoshis. If that number is present in lucky 2, we say 50 satoshis, and likewise. And if we run the code, we say R. So your lucky number is 9388 and you want 5 satoshis, and you'll hardly get a number from these ranges because the selection of these ranges is governed by the weightages here, which are very, very low. Let's try one more time. So again I get 5, but if I change the weights here to everybody to 100, 100, 100, 100 and 100, now every list is equally likely to be selected. So if I run now, I should get 10,000. So I have won $200 in just the second go. So that is how these faucets are designed, where the selection of this list is governed by the weights here. So that is how you can assign weights to these items in the lists. So random.choice is a very, very good method if you wish to select a random thing out of a list but with some assigned weight. So this was the key point here in this program. I hope you liked it, And if you like this simulator, you can download it for free from my GitHub page. And I'll see you around with an interesting Python video in the next one. Till then, take care and bye bye.